Picture a person that's sitting at a computer and looking for a laptop or a mini PC or a desktop, and they see these claims from Intel or AMD or NVIDIA, even Qualcomm, all claiming that their latest chips can do 100 tops, 30 tops, 50 tops, 40 tops. It's all over the map. And the first thing I saw a comment from somebody that when they saw that they were like, "Oh, I went out to the top 500 website and wow, I'm right up there with them." They're saying their laptop is a supercomputer, right? Well, depending upon what decade it was, yes, that is true. It is. Yes, you are. In fact, some of your phones are running faster than some of the supercomputers of the past as well. But yeah, I mean, it's funny how marketing all throughout the years will latch on to something, and that becomes the de facto way of measuring, yeah, big quotes, measuring performance on a particular machine to give you some idea of I don't know what TOPS is trying to tell me. I'm not even sure what that means. Does it really mean trillion operations per second? What kind of operations? We in the world that I come from, we talk about FLOP, floating point operations per second, and that is measured today in exaflops. So your teraflop number is not very exciting. Sorry, we haven't had teraflops since. Oh wow, that goes way back into the. I think we passed that on some weekend in the mid 1990s because there was a huge jump between gigaflops and petaflops, all within the span of about a year, and that was right at the millennium marker in the year 2000. So yeah, that's kind of how things work. So yeah, as if you're researching for a new machine and you run across these AI machines, you might see something like this. This is Qualcomm's website where they talk about what is a top and what does that mean. So, but what's the fine print? So if you read the fine print on what the top says it can be an integer 8 or integer 4 operation. It is an AI workload of theoretical performance. In other words, it's not measured. It's calculated on a blackboard, maybe even a dartboard, or a spinner. So I'm guessing it's probably more put a bunch of random numbers on a dartboard, stand 10 feet back, and then start wailing with you get three chances, and the highest number is your tops number. And if you're getting ready to specify tops on your machine, make sure it's 20 higher than the last published one by your competition. So yeah, I mean, it doesn't have anything to do with real world performance, and today we're going to prove that. So hang on, and when we get to so we got supercomputers and AI people offended now. Let's go ahead and offend the gamers too. Why not? So gaming performance is measured in frames per second for a given resolution and a given frequency for your monitor. So, but that's the thing that gamers are interested in because they don't want latency, they don't want lag between frames. And so that's a different workload than a supercomputer task, and it's certainly a different workload than an AI task. So how do we get out of this mess? As they always say, it's you got to make sure that the workload matches the design of the hardware. If it doesn't, you get crap performance. Our poor guy is sitting there, he's looking at the FPS and TPS and FLOPS for supercomputing, and he's confused. He has no idea what to do now. And then I kind of chuckled. I was looking at the Qualcomm page, and it says go to Procyon and you look at and use their benchmarks for tops. It's their tops AI tops benchmark. So if you go over there, you won't find an AI tops benchmark. What you actually see is an AI benchmark for language models to do chat. There's AI models that do image generation. There are AI benchmarks that measure the performance of image recognition Now that one could use an NPU. The other two, like the one for a chatbot and the one for image generation, those would be those. An NPU is not what you want there. Why? The NPUs are neural processors. They're great for neural processing workloads. They're horrible for AI workloads for large language models. They don't have a lot of memory. The most memory most of the NPUs have is between half a meg and a gig. That's not a lot of space to stick a model that's, up to what, up to 70 billion objects that are in it. How do we measure performance in these three methods? So today what we're going to do is there are three things that we're going to try to look at today. First, what does it take to measure the performance in the workloads of supercomputers? What does it take to benchmark a workstation that's dedicated to, in this case, one particular AI workload for chatbots? And the third is, how do we measure the performance of a machine for its suitability for gaming? So how do we figure out how fast a machine would be in the classification of a supercomputer? The answer is that's LinPack. LinPack is used for that. It's been around for years, literally decades. So today what I'm going to be checking out is this machine called the Atom X series. This particular one is an X7 Ti. This is an Intel Core Ultra 9. This is the 185. It also has an Intel Art Graphics. This would be the A-type Art Graphics card. This is not the B series. 32 gig of memory. This is called HPL, and this is version 2.3. This is maintained by the NetLib organization. I think it's .org, if I remember right. Yeah, this is it. So they have, there's LAPAC, there's LinPack, there's the HPC challenge. So they manage the collection of mathematical software. I'm going to go into I just have compiled this yesterday, so I'm going to go into here. Now I had to build this. You pretty much have to customize this from the ground up. So let's go ahead and execute this. And you'll notice, I'm going to put this up over here, that this is the problem. This is my settings for the HPL.dat. So you'll notice it's starting to do a warm up on the CPU. It's not hitting us too hard here yet, but in a minute or so, once it thinks everything is warmed up, it will go ahead and start running it on multiple cores. And the problem size I gave was 29,232. Okay, there it goes. Now it's actually running it. So it's pinning all the processors on my machine. And you'll notice I didn't have to run MPI to do that. That's all included in OpenBLAS. It manages all of that, which is really nice, because setting up OpenMPI is it takes a bit to do that. So it has completed the run. It's right here. And you'll notice that don't read the one up here. Okay, so let me explain this. So this is the precision number up here. So that's a very, very tiny, tiny number. And that's the desired precision we want from the benchmark. And this number right here is the actual result. So how many gigaflops is this machine? Well, it's 224.38. That's my gigaflops. So is this, and also this down here shows your error rate. There is a threshold that I gave it. So that's why it says you completed one test with the following results, completing and passed even the residual checks, which says that this result doesn't exceed an error rate that I had put in place in my HPL.dat. By today's standards, not so impressive. So wait a minute. these TOPS benchmarks, they're saying that, you know, you have 50 trillion operations per second. What are they talking about? If you're not getting, that's not trillions, is it? No. If it were, it'd be a +3 there. What's going on here? So let's go to the next scenario. So we're going to test AI workloads. This is the benchmark I'm going to use is llama.cpp, which is the more commonly used workload to test to benchmark performance with chatbots. What I'm going to do is I'm going to run this. And okay, we're up. So what I'm going to ask is I'm going to do my usual thing. So what domains are you trained in? Now, it's not using every CPU on the, well, that went pretty quick. So it's not using every CPU on there. As you can see, it was locked to look like maybe one or so. Here, we'll have to go look and find out. Let's go here. Let's try it again. I wish you could do an up and yeah, repeat. I'll ask it the same way. I hate this keyboard, by the way. My mic is right in the way of it too. All right, so I don't have a specific. Oh, now it answers differently. So it is using, yeah, see, as it goes, it's starting to spread the workload across more and more processors. It's getting more and more of the machine involved as it gets more complex. And then when you're done, to get the results, you just Control C to get out. And right here, now don't let marketing see this because this is the number they would float to right here. Oh my God, you got 35,000 tokens per second. Oh geez, that's huge. Yeah, but this is the sampling time. That is not the actual number that we're looking for here. So what we actually achieved was, let's see, we're looking for that's the prompt evaluation. What we're looking for is this one right here, is the context on the eval time, because the evaluation time is the actual run time. So I'm getting around 47.31 tokens per second, which is, I mean, that's respectable for a $700 machine like this one. That's very respectable. I've run Llama Llama, I should say, with an NVIDIA 3070 and got about twice that number, and that's about it. So that's not bad. And this is not using the GPU at all. I did not include that. This is, as you can see, it was running entirely on the CPU. Let's try it again, and let's see if we can get it to answer. And let's see. Let's see if, I don't know if this is able. Let's see if it can. You can write code in Go, but I'm not able to provide any Go code. All right, let's see. Let's try Python. Let's see if how context aware it is. Okay, so it can do Python. So, all right. I'm watching to see. It looks like it's consuming 4 cores at the moment. 5. There goes 5. So as the problem space expands, it's taking more and more resources on the machine. Which is kind of what you, wow. The game of life is, I picked this because it's usually that's a pretty significant game to give a program to do. Now I'm not going to go test it. I just want to see how long it takes to generate. Oh, that's good. Real efficient code there, dude. Okay, let's see how long that took. All right, so we were getting around 42.64 tokens. And this would be if marketing saw this I guarantee you this would be the new, oh, this machine gets 36,603 tokens per second. Yeah. And I'm sure if marketing saw that's the number they would use when they were advertising it. But yeah, so this is the right this is the right TPS number down here, 42.64. So what about gaming? Gaming is our last thing that we need to look at. So right. So I'm gonna use the Unigine benchmarks because they have one for Linux. The other ones that are around are mostly Windows based. But thank you Unigine for doing this. And I'll test both Heaven and Superposition so that we get kind of a more modern. I know there's some problems with the old Heaven benchmark because, I mean, it was it was originally written for 1080p. It wasn't written for these. Now I'm running on a 1080p system, so let's go ahead and bring this up, see if it runs. And let's see, my settings are high. I have tessellation disabled, stereo disabled, multi-monitor disabled, anti-aliasing off. So let's just see what we get, and then the system is whatever my resolution on my monitor can be, which is 1080p. So let's just see how well things go here. I can turn the music on if you want, but I don't think it's necessary. So it looks like about 60 frames, 62. Let's just let it run through and see if we see any artifacting or anything weird. All right, I think this is good enough. If it was going to crash, it would have crashed by now. Let's benchmark. 75.9 with this particular one. I'm going to go ahead and save that. And close and then quit. Looks like everything was working on it as far as the application. So in conclusion, what does TOPS actually mean? I'm going to leave this one to you, for you to decide. Leave your meaning of TOPS in the comments below. So anyway, that's all I had for today. Thanks for watching. I hope you enjoyed this video. A rather pointless attack on marketing once again. Anyway, I'm DJ Ware. I hope you enjoyed this. Please like and subscribe. Bye for now.